Okay. So, let's see what we can do. Anybody want to give me one way they found the answer? One way they found the answer. Vinny.
So what I did was completing the square.
You went to completing the square first, huh? Excellent. So we're going to call this method 1, and a few of you are going for this. And that's completing the square. So tell me what you did, Vinny.
So I added 12 to both sides to cancel out the 12.
All right, so you would get x squared plus 4x is equal to 12.
And then I get x plus 2 squared to change to the same form.
Well, you skipped a step there. How did you get x? Because that's not x plus 2 squared.
Oh, you have to divide the 4
there
by
you
2
go.
and then square it to get.
All right, so we completed the square by dividing the 4 in half and then squaring it. So half of 4 is 2, 2 squared is 4. And you added that to both sides, right?
Yes.
Okay. So then what you got was what?
I got x plus 2 squared.
Right, because this factors into x plus 2 times x plus 2. That was the whole point of factors into a perfect square. So this is x plus 2 squared is equal to 16. Okay, now what you do?
I took the square root of both sides and I got x plus 2 is equal to 4.
So you got x plus 2 is equal to 4. And then what?
I subtracted 2 from both sides and I got x equals 2.
Okay, now he subtracted 2 from both sides and he got 2. He is 90% there. He made one common mistake. Positive or negative 4, because when you take the square root of 16, there are two numbers you can square to get 16. Positive or negative 4. Now when you subtract 4, you have x is equal to negative 2 plus or minus 4. So you can do it. You can think of it two ways. You can think of it as 4 minus 2 and negative 4 minus 2, or you can think about it as x is equal to negative 2 plus 4, which is positive 2, negative 2 minus 4, which is negative 6. In either case, 2 and negative 6 are your answers. That was completing the square. Anybody do it a different way? Different way. Addie, how'd you do it?
I factored.
Factored it. So tell me what you did. We're going to call this method 2 factoring.
I did, since 6 and 2 could be multiples of negative 12.
Uh-huh.
I did a positive 6 and a negative 2.
Excellent. And equal to 0, right? And then what did you do?
And then I did x plus 6 is equal to 0 and x minus 2.
Now, why did you set each of those two factors equal to 0? That's a good question, ladies. Why did you set each of those two factors equal to 0?
Because those are the actual values for the x. I don't know.
Close. You want to help her out?
Equals 0 times 0 equals 0.
Right, because 0 times 0 equals 0. But there's a law of property called that. What is it?
0.
The zero product property says that if you have two factors being multiplied and the product is 0, either one or both can be 0. So if you set each factor and figure out what makes that factor 0, it's going to work. So that's what you did. Now, we do not want to just look at that and say, well, the opposites of the numbers in the parentheses. That would be one of those sort of lack of understanding sort of shortcuts that we always try and get because it's so tempting, right? All you got to do is take the opposite, but if this were 2x plus 6, would that negative 6 still work? Nah, it would be bad. So don't do that. Go for the understanding. It's whatever makes this factor 0 or that factor 0 that's going to make the whole thing equal to 0. Okay? So that is factoring. Now, anybody do anything else? Owen. Yep, you can put it in your calculator. I'll look at the calculator in a second, and you can find where it crosses the x-axis or the 0 function. Anything else? Now, in Algebra 1, and this is what today is all about, you learned about the quadratic formula. In other words, x is going to be equal to negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. That's called the quadratic formula. And you know that. You've seen that before. It's maybe a little old and a little stale, but we've seen it. Now, I put that b squared minus 4ac in red for a reason. Does anybody remember what that's called? It's called the discriminant. That's called the discriminant. Okay? That tells you a lot about your solution. If the discriminant is a positive number, you're going to have negative b over 2a plus or minus the square root of a positive number. So your solutions are going to be real numbers because you're taking square roots of positives. Can we take square roots of negative numbers? No, that would yield imaginary solutions, not real solutions. Also, if it's a perfect square, like 25 or 16 or 121, whatever, you're going to have nice, pretty round fractions or integers. If not, you're going to have irrational solutions like pi, square root of 2, things like that. But first things first, you may have also seen this as negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a common denominator in two fractions, so you can put them together like this. So you can see these in either way. They're both fine. I like this way because does anybody remember what negative b over 2a is something else? Can you remember what it is? Negative b over 2a? It's close. It does have something to do with the turn, but it's not the entire turning point. What is it? It's the x value of the turning point, or the axis of symmetry. So if you have a parabola and you're looking for the x-intercepts, you can think of the first piece here as being the axis of symmetry, or the x-coordinate of the vertex. And then this plus or minus is just plus and minus is the distance between the axis of symmetry and each of the solutions, which are here and here. So you can think about it that way as well. I like it that way. It gives it more meaning, gives it more graphical, more pictorial, more of a picture. It makes more sense. You can visualize it a little bit better. So the first thing to do is the discriminant, because that's going to tell us about a solution. So kids make a host of different mistakes with the quadratic formula. Try and do it this way or some way similar, and it'll cut down on your mistakes. Because kids understand the quadratic formula, they get it, but it's always the order of operations, or simplifying radicals, or something tedious, or them trying to do steps in their heads. That's where the mistakes are. So I always tell kids to do the b squared minus 4ac first. It makes the calculation easier, and it tells you about your solutions, what they're going to be first. So pull off your a, b, and c. A is equal to 1. B is equal to 4, and C is equal to negative 12. So b squared minus 4ac, 4 squared minus 4 times 1 times negative 12. Now, you want to try and do these in your head, because let's face it, we can't count on the calculator too much. That would be a little embarrassing, right? So we want to do them in our head first, but we always want to check in your calculator. And the reason why I put them in parentheses is because that's exactly how you would put them, and you put it in your calculator. So let's get our calculator real quick. Now, I'm looking at this, I'm thinking exponents first, that's going to be 16. The minus comes last, because addition and subtraction comes last in the order of operations. And then multiplication. So 4 times 1 times negative 12 is negative 48. And then I can go ahead and do my addition and subtraction. So that's going to be 64. That's my discriminant. But if you put it in your calculator just as you have it here, that's going to give you the exact same answer. If you plug in negative 4 without that parentheses, do I get the right answer? It does that because your calculator looks at negative 4 squared without the parentheses is negative 1 times 4 times 4. It only applies the square to the 4, not to the negative. So it looks at negative 4 squared as negative 16. So, for safety's sake, put it in parentheses, you won't have a problem, okay? Okay, so. That discriminant comes first. Now, then I tell kids go ahead and do the rest of the quadratic with your discriminant. So now for part 2, you're going to figure out what the solutions are. But I look at that 64. 64 is a positive number. So I know that I'm going to have real solutions. Square root of a positive is fine. 64 is a perfect square. So I don't have any ugly radicals left over. The square root of 64 is just going to be 8. So I'm going to have nice rational numbers for my solution. But if they were negative, square root's a negative is no good, you're going to have imaginary solutions. If it was 0, you would have negative b over 2a plus 0 and minus 0. Isn't 2 plus 0 and 2 minus 0 still 2? So you're not going to have two solutions if it's 0. You're just going to have negative b over 2a plus and minus 0. So your answer is only going to be negative b over 2a. So if any of these things don't seem obvious to you or whatever, you should be writing them down. A lot of information just came out of my mouth. Any questions? Okay. Now, whoops. Okay, now, where'd it go? There we go. So, let's do that second piece. So x is going to be equal to negative b over 2a. You already have it up there. So negative 4 over 2 times 1 plus or minus the square root of 64 all over 2 times 1. Now, you're in Algebra 2 now, not Algebra 1. Algebra 1 teachers tend to force kids to show more and more steps because it helps them cut down on mistakes, it helps them understand their mistakes, and it helps teachers troubleshoot their mistakes. But I'm okay with you guys doing negative 4 over 2 is negative 2. I'm okay with that. But if you don't see that or you get that wrong, you need to show the step so you get used to it, okay? So this is going to be negative 4 divided by 2 is negative 2. And then plus or minus, the square root of 64 is 8 over 2. So it's going to be negative 2 plus or minus 4. And just like over here, we have negative 2 plus 4, negative 2 minus 4. That's going to be negative 2, it's going to be positive 2, and negative 6. Okay, so I've got 3 of the same answers, and it shouldn't change with a different technique, right? And I'm all set. Any questions? Any questions on the quadratic formula? Okay. Well, I'm going to leave my work up there so you can see it. That's good. And I'm going to let you get started on the problems for them.